The name of our experiment is the colored ice cube experiment. In our experiment, we will be using food coloring to color each ice cube and measure which cube absorbs the most light, causing it to melt faster. We will have 5 trays of ice cubes, each tray containing a different color. We will have 1 tray with no dye, 1 with yellow dye, 1 with green dye, 1 with red dye, and 1 with black dye. Each tray will contain the same amount of dye and the same sized ice cubes. They will also be in a freezer for the same amount of time. Once the ice cubes are frozen, we will record the temperature and humidity outside. Leave 1 of each ice cube in the sun and measure which one melts the fastest. We will repeat this experiment 12 times to make sure our results are accurate. We are aware of the fact that the darker objects absorb more light. White light is made up of all sorts of different colors of light. When light hits something, some of the colors are absorbed by the object. This is important because the light that is absorbed heats up the object. Although, altering the water with different chemicals and substances could also decrease the melting rate. Our hypothesis is that the ice cube with the darkest food coloring will attract more light, causing it to melt faster than the other colors. Our independent variable is the color of food dye. The dependent variable is the amount of time it takes for the ice to melt. Our controls are the size of the ice cube, the freezing time, the amount of food dye, and the location of the melting. Our materials include ice trays, water, a freezer, food dye, a timer, and an outdoor area to perform the experiment. First, we will fill 5 trays, 1 for each color. Then we will put 2 drops of food coloring per ice cube. Each tray contains a specific color of food dye. No dye, yellow, green, red, and black. We will keep the trays in the freezer for 7 hours. Once the ice is finished freezing, we will put 1 ice cube of each color in the sun and record the time it takes to melt. We will make sure to keep track of the temperature outside. We will repeat this experiment 12 times to make sure our results are accurate.
This is our data for the yellow ice cubes. For round 1, the temperature was 70 degrees out with a humidity of 53%. For round 2, the temperature was 72 degrees out with a humidity of 56%. These are our statistics for the yellow ice cubes. And this is our histogram and pie chart for the yellow ice cubes, along with our scatter plot and box and whisker plot. And these are our t-test results for the yellow ice cubes.
These are our results for the red ice cubes. For the first round, the temperature was 70 degrees and the humidity was 53%. For the second round, the temperature was 72 degrees and the humidity was 56%. These are our statistics for the red ice cube. This is our histogram and pie chart for the red ice cube. And here is our scatter plot and box and whisker plot. These are our t-test results for the red ice cube.
This is our data for the green ice cubes. For round 1, the temperature was 70 degrees with a humidity of 53%. For round 2, the temperature was 72 degrees with a humidity of 56%. These are our statistics for the green ice cubes. These are our histogram and pie chart for the green ice cubes. And this is our scatter plot and box and whisker plot for the green ice cubes, along with our t-test results for the green ice cubes.
This is our data for the ice cube with no dye. For the first round, the temperature was 70 degrees and the humidity was 53%. For the second round, the temperature was 72 degrees and the humidity was 56%. These are the statistics for the ice cube with no dye. As you can see, the average melting time is 32.48583, which is the longest out of the 5 ice cubes. This is our histogram and pie chart for the ice cube with no dye. This is the scatter plot and the box and whisker plot for the ice cube with no dye. Here are results for the t-test for the ice cube with no dye.
Here's our data for the black ice cubes. For round 1, the temperature was 70 degrees out with a humidity of 53%. For round 2, the temperature was 72 degrees out with a humidity of 56%. Here are statistics for the black ice cubes. The average melting time of the black ice cube is 23.48583, which proves it melts the fastest. Here's a histogram and pie chart for the black ice cubes, and a scatter plot and a box and whisker plot for the black ice cubes. Here's our t-test results for the black ice cubes.
Here's a time lapse of us running our experiments. A t-test shows the difference between two groups of data, including average, size, and standard deviations. This is significant to our data because the difference did not occur, which proves our data was accurate. Our detailed analysis is that when comparing the average melting times for the different colored ice cubes, the yellow, red, and green ice cubes had a mean of about 27 or 28 minutes. The ice cube that contained no food coloring had a mean of about 32.5. The black ice cube had the fastest melting time with a mean of about 23.5. The first round of experiments contained 6 of each colored ice cubes, and the temperature was 70 degrees, and the humidity was 53%. The second round of the experiment also contained 6 of each colored ice cubes, but the temperature was 72 degrees and the humidity was 56%. Because of the warmer environment in the second round, the ice cubes melted faster, yet we still received the same result, therefore making our conclusion even more reliable. In conclusion, our hypothesis was correct. The ice cube containing the black food coloring melted the fastest. The reason for this is because darker colors attract more light. Therefore, the black ice cube attracted more heat, causing it to melt at an average time of 23.5 minutes. This is about 9 minutes faster than the ice cube with no dye, which had a mean of 32.48583 minutes, demonstrating a great difference between the ice cubes. The red and green ice cubes also had a faster melting time because they are darker sides of the color spectrum, and the yellow ice cube's melting time was only slightly greater than the one with no dye because yellow is a very light color. Each ice cube contained 2 drops of food dye and were in the freezer for 7 hours. They were also the same size and the experiment was performed in the same temperatures. We used a total of 60 ice cubes, 12 for each color, and each time the black ice cubes melted first. All of these factors demonstrate the accuracy of our result.